All right, good morning everybody. Let's do this. So the game plan for today is what are the techniques for computing limits without a graph, all right? So here, the first part will be very straightforward. If we have a constant, linear, and or a polynomial function, these limits are very straightforward to evaluate. So let's look at a constant function. A constant function is some f of x equals c, where c is a constant. And what do we mean by that? If I have the graph, the limit, if I just have the graph, y equals 6, right? For this graph, all you have is a horizontal line at the y value of 6, and this is your graph. And notice that, here for x equals 1, what's your y value? It's 6. X equals, 10, like if it's over here, your y value is still 6. So here, whenever you have a limit, and it's saying what's the value at x as x approaches 4, it's just always going to be 6. So this is just 6, right? So for some constant function, the limit just goes to whatever this y value is. Like the same idea here, like if I say x is going to 1,000, at x equals 1,000, this limit is still at 6, right? What about at the limit of, what about this graph? Y equals -4. Well, here it's just a line just over here, 1, 2, 3, 4. It's 4 below the x-axis, and it's just a horizontal line like this. And as you go to -infinity and +infinity, no matter what x value you have, your y value is just going to be -4. So as x approaches +infinity, what is your y value? Your y value is just -4, so it's just -4, okay? So this is an example of a constant function, very straightforward. Let's go to the linear one. Here, if you have a graph, some y is equal to mx plus b, this graph over here, 2x